Sorry, camera died. So we said that we have VF equals 0, and we are looking for the maximum height, which is y distance, and we're also looking for the range, which is your x distance. First, let's find time. So I know for y, I have VIA, VF, and I'm looking for t, so that's that first equation. VF equals 0, VI is 29.64, acceleration is negative 9.8 t. I'm going to subtract this over, and that gives me negative 9.8 t divided by negative 9.8, and that gives me my t up is 3.02 seconds. And then to find t total, because we are talking about an angled projectile that goes up and down, I would just double, so that would give me t total 6.04. Now to find the maximum height, y distance, I would use a y equation for distance, so d equals VIT plus 1/2 AT squared. VI would be the y velocity. I would use t up, because we're talking about at the top. 3.02 plus 1/2 negative 9.8, 3.02 squared. And that gives me a y distance of 44.81 meters. So that is my maximum height. And then the x distance, I would use my x equation, v equals 0 t. I'm using my x velocity, 43.94. Looking for distance, and I'm looking about the x distance, that's at the very end, so I'd use t total, 6.04, and then I'd multiply that 6.04 up, and that gives me an x distance of 265.39. A ball is thrown and follows the path shown. Air friction is negligible, means we can ignore it. Point Q is the highest point, and P and R are the same height. How do the speeds compare? We're not worried about like positive or negative, just which is faster or slower. So I'm looking at P and R, so because these are at the same height, I'm going to say those are equal, because I know this is symmetric, right? So at the same height, they would have equal speeds. One will be right and up, this one will be right and down, but it's still the same speed, just different directions. And at the very, very top, I know that Vy is 0, I'll still have my x velocity, so this is going to be the slowest. And the reason it's the slowest is because my x is staying the same at everywhere, but my y just got slower on the way up, so this would be the slowest before it starts to get faster again. So Q is the slowest, and then P and R are the same, so that's D. Q is slower than these two, which were equal. Direction of the acceleration at point P, so acceleration is just talking about gravity, the negative 9.8, which is going to point down, so the arrow that represents acceleration would be D. Direction of the velocity, total velocity at point P, well, at point P it's going to be going up and over, so that would be A. Direction of the acceleration, well, at any point the acceleration is going to be gravity, D. The direction of the total velocity at point R, so at point R it's going down and over, so that would be C. Total velocity at point Q, so point Q only has x, no y velocity, so that would be B. We've got a wiffle ball tossed up at an angle, reaches the highest point, and falls back down to the same height. Air resistance is negligible, which is true. So talking about at the highest point, the velocity is 0 at the highest point. The acceleration is 0, and it takes a longer time to travel up than to fall back down. Well, we know t up and t down are the same, that's why we just double it to get t total, so that's not true. The acceleration is 0 at the highest point, that's not true, your acceleration is negative 9.8. And the velocity is 0 at the highest point, only my y velocity is 0 at the highest point. You still have x velocity, which means that it's not 0, right? I still have an x velocity, so that was not true either, none of them were true. We've got an elastic balloon launcher, 60 degrees, initial velocity of 25, so first things first, Vix is going to be 25 cosine 60, and VIY is going to be 25 sine 60. So VIX is, when you put that in your calculator, you get 12.5, and VI for Y, you get 21.65. You can, of course, put your acceleration, and we are talking about an angled projectile. VF is 0 at the top, that's later on, which is why it's VF is 0, not VI. Also, I already have an initial velocity. Finding the time it takes to get to maximum height, that's just asking for t up. So I'm going to use VF equals VI plus AT. So 0 equals 21.65 minus 9.8 t. Subtract over, divide the negative 9.8, and that gives me t up is 2.2 seconds. Maximum height is asking for y distance. I'm going to plug into my VIT plus 1/2 AT squared. Initial velocity for y is 21.65. T up, because we're talking about the height at the very, very top, so we use T up. 1/2 negative 9.8, 2.2 squared. So that gives me a y displacement of 24.11. Total time it's in the air, well, I know it takes 2.2 seconds to go up, so it'll take 2.2 to go down, so then T total would just be double that time, or 4.4 seconds. How far away when they hit level ground? How far away is asking for the x displacement. X, we always use v equals d over t. We're using our x velocity. We're using the total time, because the very, very end, right? Total time, not the maximum height at the top. So 4.4, and then I multiply that up, and that gives me an x distance of 55 meters. Finding the ball's total velocity 5 seconds into the flight. So I already know my x velocity, it's 12.5. I need to know what my y velocity is at 5 seconds. I know the initial y velocity, that's at the very, very beginning. It's changing. X is not, so I can just keep it the same, but this one is changing, so I need to use VF equals VI plus AT. I know the initial y velocity is 21.65. I know the acceleration. I'm looking at 5 seconds, so I'm finding what the y velocity is after. So when you put this in, I got my y velocity is negative 27.35. And then, because I know my x and my y velocity at that point, now I can use v total equals vx squared plus vy squared. This is basically a squared plus c squared equals c squared, my hypotenuse. So x is 12.5 squared plus y is negative 27.35 squared. You have to put parentheses to make sure that negative sign gets squared. So that gives me what v total squared is, which is 904. And then that's what v total squared is, not v total. So now you take the square root and you get that v total is 30.07. So step 1 is using that first equation to find your y velocity, and then after that it's Pythagorean theorem. X velocity squared plus y velocity squared equals hypotenuse squared. A ball is thrown at an angle of 38 degrees. What happens to the magnitude of the vertical acceleration during the total time that the ball is in the air? Your vertical acceleration is negative 9.8 at every single point, so it remains the same. Marble rolls off a table and lands 1 meter away. The table is 1.3 meters tall, so this is going to be a y distance, and it's going to go down 1.3 meters if it's rolling off the table. This is an x distance, and then of course I can use acceleration, and for a horizontal projectile, it's the initial y velocity that's 0, because I'm not going up. How fast did it roll horizontally is asking for your x velocity. First we're going to find time, so I have dA and VI's. I'm going to use the d equals VIT equation to find time. So negative 1.3, 0t, because I'm using all y values here, because I don't mix and match. Divide the negative 4.9 over. That gives me that t squared is equal to 0.265. And then that's what t squared is, so I need to take the square root, and that's going to give me t is 0.515. And then now that I have that, looking for how fast it rolled horizontally, so v equals d over t is x distance, 1 meter over the time. So I'm looking for x velocity, so then my x velocity is 1.94 meters per second. I do not double time here because it's just falling down. It's not going up and down. There is no t up and t total. It's just the time. Field goal attempt. We're looking at maximum height. What do we know about the speed? So looks something like this. At the very, very top, it might be tempting to say your speed is 0, but actually only my y part of my speed is 0. I still have an x velocity, so it's not going to be 0 because you still have vx. It is not equal to the initial speed because at the beginning I had x and y, right? And it's not greater because I actually lost the y velocity. I only have x here, so that means it's going to be less. So it's slower here than it was before, but it's not completely 0 because only the y velocity went to 0. For the next one, these horizontal projectiles, we're asking which one hits the ground first. So we're talking about time. When we're talking about time, we actually, so least time, right? Hits the ground first is less time. that means less y, because we're talking about time, we only care about y, so whichever one has the less y is our answer. So B has the less y distance, so that's the one that hits the ground first. Which one lands with the slower velocity? When we say velocity, and I didn't specify like x or y, that means like total velocity. So think about, this one has less x velocity, and when it hits the ground, it'll have less y velocity because it didn't have very long to accelerate. This one had longer to accelerate. So B would be your answer. Lands closest to the table, so when you're looking at the x distance, you actually care about both x and y. So this one has the less x and it has less y, which means I'm going slower and I'm doing that for less time. So of course B would for sure land closer to the table. Here they both have the exact same initial velocity. They have different masses, so they'll have the same acceleration, they'll have the same time, they'll reach the same height, they'll have the same speed at the top because the mass isn't going to affect that. When you think about our equations, we never plug in mass when we're plugging it in to find the max height or the time, etc. And I showed you with the demo at the front, right? Paper goes slower not because it has less mass, because of air resistance. So if I crumple it up, it's actually going to fall at the exact same rate. And we're ignoring air resistance in all of ours. These two, which one has a greater range? Range meaning x distance. So if I look, they both have the same y, which means we'll be in the air for the same amount of time. This one has a greater x velocity, so it's going to go farther in that time. Greater vertical velocity lands with the greater vertical velocity, while the y part, it'll be in the air for the same amount of time, following the same distance with the same acceleration, so they should land with the same exact y velocity. Which one lands first? So the talking about time here is, not here, but time is always determined by the y part. They have the exact same y height, so they're going to land at the exact same time. Faster total velocity, so they're going to land with the same vertical velocity, but this one has a greater x velocity. So if you think about, like if these are my arrows, they both have the same y, but this one has a greater x velocity, so this one has a greater total, B. Same y with a greater x means a greater total. Speed at the top of the path. At the top of the path, your y velocity is 0, but you still have Vx. In fact, because y is 0, you only have Vx. Whenever I ask the greater speed at the top, that's just asking for a greater Vx. If you look at these, this one has a greater initial y velocity, this one has a greater x velocity because x is sideways. So this one has a greater VIY, this one has a greater VIX. And we know the x velocity is constant, so at the top, right, whoever has the greatest at the top is just the one that had the greatest x at the beginning, so B had the greater x. Air longer, so that's talking about time, so more time is just the one that has more y. If we look, we just said this one, that's an arrow by the way, this one has a greater Vy, so then your answer is A. Because it has greater y, it'll have a greater time, and reaches a greater height. Again, greater height comes with more y, and the more y was A. Farther range again, still meaning x distance. So if you look, x distance, this one has a faster x velocity, and they're going to be in the air for the same period of time, so this one will go farther. Which one has a greater maximum height? So max height, you just care about the y. If you look, they have the exact same y initial velocity, so they reach the same height. Which one's in the air longer? So time, we're looking at the y part. They have the exact same y, so they'll be in the air for the exact same amount of time. A toy car rolls off the table with a velocity of 0.8. It hits the ground 0.4 meters from the edge of the table. How high is the table? So this is a horizontal projectile, how far away it lands, and how fast. Those are both x velocity and x distance. I, of course, have my acceleration for y, and because this is a horizontal projectile, the initial velocity for y is 0, not vi. I'm always going to find time first, and I'm looking for how high the table is. That's a distance, but for y. So first I need to find time. I'm going to use v equals d over t, because I have both of these. So v equals d over t. I have 0.8 equals 0.4 over t. Now, because my unknown is on the bottom, the very first thing I'm going to do is multiply the t up like this. That crosses off, and now I have t 0.8 equals 0.4. To get t by itself, I'm going to divide the 0.8 over so I can cross that off. And then 0.4 over 0.8 is just 0.5. So that's my time. And then lastly, I want to find the y distance. Y distance, I'm going to use my d equals VIT plus 1/2 AT squared. VI for y, because we're plugging into a y equation, is 0 times 0.5 plus 1/2 negative 9.8 0.5 squared. 0 times 0.5 goes away. 1/2 of negative 9.8 0.5 squared. You just type into your calculator, and you get negative 1.225 meters. And the reason I'm getting a negative is just it fell down that many meters, so it's not a big deal. It just means it went down. Balloon launcher fires balloons at an angle of 34 with this initial velocity. So first things first, I'm going to do 8 cosine 34 to get VIX, and that gives me 6.63. And then I'm going to do 8 sine of 34 to get my initial velocity for y is 4.47. Of course, I have the acceleration, and then my y final velocity is going to be 0 at the top. The time it takes to reach the top of the path, I have VI, VF, and A, so VF equals VI plus AT. 0, use your y velocity, oops, that's a 5, minus 9.8 t, subtract over, and then we're going to divide that negative 9.8 over, and that's going to give me that t up is equal to 0.456. Total time would just be double that, so t total is just 0.912. And maximum height is y distance, so d equals VIT plus 1/2 AT squared. Make sure you use your y initial velocity. We're talking about the maximum height, so I'm going to use t up, not t total. So 0.456 plus 1/2 negative 9.8 0.456 squared. And then now you literally just type it in, and you would be getting 1.02 meters. I would not be getting a negative distance because I am going up here. Here I was going down that many meters, this one I'm going up, so it is positive. How far away the balloon lands is asking for your x distance. X, we always use v equals d over t. Use your x velocity. And I'm looking at the very, very end for the x distance, so I want to use t total, the 0.912. And now we're just going to multiply that 0.912 up, and that gives me an x distance of like 6.04 something. You don't have to put all the decimals. I don't know why I did 3 in this case. And the total velocity at 0.2 seconds. So I know I'm going to use v total equals vx squared plus vy squared. I already know vx squared because it's not changing, right? It's going to stay this because it's constant. And then now I need to know, what vy is. I do not know vy at 0.2 seconds. I know vy at the very, very beginning. That is not the same thing. So I'm going to plug into that equation, put in my initial velocity, the acceleration at the time I'm looking for, and that's going to give me my y velocity after 0.2 seconds is 2.5. So that's what my y final velocity is. So then, or call it vy. So then now I can do x velocity squared plus the y velocity at the time I'm asking for squared. And that's going to give me 50.257. But that's not my answer because that's what v total squared is. So then to get v total by itself, we take the square root, and that gives me a total velocity of 7.09, which is reasonable, right? If I have a velocity of 6 and 2, then the hypotenuse at 7 is reasonable. Hypotenuse of 5 or 50 is not very reasonable. Ball leaves a 14-meter high building, so that is a distance for y, and it's going to go off the building, so it's going to go down 14 meters. Of course, you have acceleration, initial horizontal meaning x velocity is 3.5, and horizontal projectile vi would be 0 here. How far away does the ball land? That is an x distance that I'm looking for. So first you're going to use this side to get time. So d equals VIT plus 1/2 AT squared, negative 14, 0t, 1/2, negative 9.8 t squared, negative 4.9 t squared, because 1/2 of 9.8 is just this. Now I need to divide the negative 4.9 over. T squared is 2.857. That's what t squared is, so now I need to take the square root, and you get that your time is 1.69. And then lastly, I want the x distance, so x equation v equals d over t. Use your x velocity. use the time I've been given. I do not need to double here because I'm just talking about falling down, not up and down. It's not t up and t total, it's just t. And last step, you multiply up and you get your x distance is 5.916.